good evening or afternoon, I guess, depending on your point of view. Let me get my share going. Well, hello, my name is Nate Schutta. I am a developer advocate at VMware, although the best way to describe me, frankly, is architect as a service. I will admit the first time somebody called me that, I thought, yeah, that seems about right. That's kind of what I do. I go places, I talk to people, I help them with interesting architectural issues. And then I sounded the acronym out in my head and I realized it may not actually have been intended as a compliment, but neither here nor there. I still like it, so I'm rolling with it. So I do have the chat open in my eyeline. So if you have questions as we go, feel free to throw them in there. I may not answer them immediately. I may wait till sort of a natural stopping point, or I can also look at them at the end as well. And I'll try to leave a little time at the end to make sure we can discuss anything that pops up as we go here. So I've written a couple of reports that might be of interest to you if you're kind of in this space. A couple of years ago, I wrote down my thoughts on kind of what does it mean to be an architect? What does it mean to think architecturally? So you can snag that from us if you're so interested. Now, obviously, you're sitting here listening to me talk about microservices. And so if you're looking for kind of a pros companion to go along with what I'm going to say today, I've got one of those for you too. To kind of give you a sense of where this material came from, it actually began with some client work that I did with Matt Stein. I don't know how many years ago now, because time has no meaning in a pandemic. And basically, Matt and I were locked in this windowless conference room trying to talk this client off the ledge of, no, not everything needs to be a microservice. And so after, I don't know, the first day or so, Matt wrote these principles up on the board and said, listen, if we don't need one of these things, we don't need a microservice. And I jotted that down and said, hey, you mind if I turn this into a blog post? And he said, knock yourself out. So I did that. And then my editor was like, hey, this is really great. We want more. And so that evolved into more. And then I built this presentation. And then I thought, hey, I probably need a report to go along with that. Thus was born the PDF. All right, so let's dive in. So the cloud, to be clear, gives us a lot of options. And for better or worse, there are a lot of developers who think that if I'm doing cloud, I got to do microservices. And so people spend a lot of time thinking about domain-driven design, and they look around for bounded contexts, and they try to come up with ubiquitous language and running off and forming a two-pizza team, and they skip a really, really important step. And sort of paraphrase my favorite fictional chaos mathematician, your developers were so preoccupied with whether they could, they didn't stop to think if they should. And undoubtedly, that has led to some fairly serious pain in a lot of organizations. Not uncommon to see call trees that look something kind of like this, where you're not even entirely sure who calls what, and what happens if this goes down. I don't know. Can we actually even reason about what happens when the new customer event actually occurs? And that's led to some pain. Let's just be honest. Now, there's a lot of good reasons to adopt microservices, but it should be very clear that in technology, there's no such thing as a free lunch. And it's on us to make sure we understand the pros. Oh, well, that was weird. Not sure why that was doing that. My apologies. Something decided it very much needed my attention on my computer. There we go. Good times. We need to understand pros and cons, and we need to understand that there are no free lunches in software, and we need to know what the sort of added complexity is actually buying us. Is this actually something we need? Do we actually benefit from this? There are two types of complexity in applications. There's the essential complexity, that just what we do is hard. The domains that we're dealing with are hard. There's tough problems here. But then there's this accidental complexity, things that we do just to kind of make it harder and don't really give us any benefit, but they sound good. Maybe they're noisy technologies or however you want to phrase it, but we really need to avoid accidental complexity wherever possible. And so one of my soapboxes for the last few years has been trying to get people to understand that you need to know when microservices make sense for you and when they don't. Right now, again, this started out as a blog for me and has kind of evolved from there. But let's level set on what we even mean by microservices. Kind of amazing to me how often we have debates about terms in this industry, but fundamentally, it's a reaction to the monolith and these heavyweight SOA-y things that we used to write, as well as just the reality of what the cloud gives us. Now, I've been on plenty of monoliths. They're not a lot of fun. Your developer productivity tends to be low, and it can be really hard to get your head wrapped around these ginormous code bases. It take a long time for new developers to get up to speed. And geez, why do we do quarterly releases? Well, any one small change means I got to build and deploy anything anyway. So I might as well wait till I have enough to make it worthwhile to go to production. And I can't just scale the parts of the application that need the extra capacity. I've got to scale the whole darn thing. And man, these monoliths can be really hard to evolve. Ultimately what this boils down to is the second law of thermodynamics. We all ran into this at some point in our educational career. And of course, I refer to this as the teenager's bedroom problem. I am the proud owner of a teenager. At some point over the last year and a half, I was putting something in his room or taking something out of his room and couldn't really find the floor. And so I suggested to my wife, hey, maybe we should ask the kiddo to clean up his room. And her response to me was, what hill do you want to die on today? And I recognized not that one. Now, as much as I wish my son's room was more organized, I wish my office was more organized. I realized at the end of the day, the universe just wants to be disordered, and software is not immune from this. There's no getting around it. The longer you do this, the more you realize that, modularity breaks down and just takes longer and longer to add new things. I think this is part of what sort of gave birth to this quote unquote new architectural style known as the microservice. Now, we could probably spend an hour just debating, what is the definition of a microservice, and is this really a microservice or not? It's very much I'll know it when I see it. It's in the eye of the beholder, which leads to one of my all-time favorite tweets. This is my old boss, Andrew Clay Schaefer, who wants to argue about the definition of made-up words with me. Now, I'm rather partial to anything that reminds us that these things are supposed to be small. So anything that can be rewritten in 2 weeks or less is a pretty good fit for me, plus or minus, because that's about an iteration for most teams. And, if I blow an iteration, that's not the end of the world. I can recover from that. Now, that does lead to a fascinating question is like, well, how small is small? Like, how big should a microservice be? And Sam last summer did a great video on this, where he makes a wonderful point that the more you do this, the more comfortable you get with microservices, actually, the smaller they will become, because you'll get good at it and you'll buff off a lot of the friction and things that before you're like, oh, I'd never make that a microservice. Now you're like, oh, that's no problem. And so they will ultimately tend to get smaller over time. Now, some people say, well, it's anything that's written by a 2-pizza team. Now, I don't love that definition for a number of reasons. Chief among them is the fact that that 2-pizza team definition doesn't tell me how many services that 2-pizza team can handle. Is it 5? Is it 10? Is it 20? I actually had a director ask me this once as we were sort of migrating to the cloud. And I had to say to him, well, it depends. And he didn't like that answer. But it does depend. It depends on the volatility of those services. If those services are really volatile and they're changing all the time, that 2-pizza team can probably only handle 4, 5, 6, 7, a small number. If those services are really stable and refined and they're not changing all that often, guess what? That same exact group of developers can probably handle 10 or 15, maybe even 20. I don't know. Now, it is important to understand that, maybe microservices aren't really that different anyway. They're just tiny monoliths. There's something to be said for that definition, quite honestly. I do think ultimately we should look at these in terms of characteristics. These are suites of small, focused services that do one thing. They do it well. It's the literal embodiment of that Linux, Unix idea of let's take really simple tools and pipe them together to get more complex results. They should be independently deployable, although this does get violated fairly frequently. A friend of mine was telling me that in his previous organization, they had 7 microservices that if you modified any of the 7, you had to redeploy all 7 of them, and you had to do it in the right order, or else the databases didn't initialize properly. And he recognized that wasn't the best way to do it, and they wanted to change it. But there's always debates around that in projects, and everything works, it's fine. They should be independently scalable. They should evolve at different rates. Now, developers love microservices because they give us the freedom to choose the right tech for the job, which we tend to abuse as, oh, thank goodness, now I finally have an excuse to put insert esoteric language or technology or database on my resume, because microservices means I can just use whatever I want. We'll get to that here in a minute. They should be built around business capabilities, and they are ultimately another example of what I refer to as the 0th law of computer science. So many of the things we're trying to do in computer science boil down to this. It's high cohesion, low coupling. And that's really what microservices are. We want low coupling. We want this service to do one thing and do it really, really well. And that should be its focus in life. So really, that's what we're trying to do here, is apply high cohesion, low coupling to services. Now, friends, it's an approach, it's a style, it's a pattern. It is not Mjolnir. It will not solve every problem you've ever had on any project. And besides, you must be worthy to pick it up. And I know a lot of us have sort of framed it as this is the answer to every problem we've ever had. It's not. It's a tool. The challenge for us is to know when to pick up which tool. No, I'm a software person. I'm not very good at hardware, so I'm not particularly handy around the house. I guess if there's a YouTube video that's sufficiently detailed and it's literally just clamp here, insert this there, I can probably do it. But a lot of other things, like it's out of my pay range. Like I can't do that. So for me, one hammer is more than sufficient to basically screw up any project around the house. Now, a couple of years ago, my wife and I decided we wanted a little more living space, and so we finished our basement, by which I mean we hired someone to come in and do the work because I wanted it done in my lifetime and I wanted it to be of good quality. And so the folks that came to work on my house, they didn't just have one hammer. They had a whole truck full of hammers. If you've ever gone to a big box, home improvement retail type store, they have a whole aisle full of hammers, and they're different sizes and different weights and different handle material. And, some have a face that's kind of rough and some don't. Some have a little hook on the end so you can pry out the nail you bent while you're trying to pound it in, et cetera, et cetera. The challenge for us is knowing when to pick up which hammer. And that's really the difference between someone like me who doesn't know what they're doing when it comes to home improvement and someone who does. The other problem I see a lot in software is we have this tendency to fall in love with the first hammer we ever used. And so if the first project you're doing is demolition and I hand you a sledgehammer and you're knocking down walls with the sledgehammer, you think, oh my God, the sledgehammer is the best hammer in the whole toolbox. And then I ask you to do something that requires a defter touch, like maybe put up some nice maple trim, and you go, oh, I got a sledgehammer. This will work really well for that. You're going to break your thumb, and you're probably going to destroy that maple trim and dent up your wall. It's not going to end well. And so that's the challenge for us, is knowing when to grab which tool and knowing that we need to use them wisely. And it's vitally important to understand that if you can't build a monolith, microservices aren't going to be any easier. In fact, it's going to make things worse in many ways. Now, this might be one of my all-time favorite tweets, and I'm just upset I didn't think to tweet it before Matt did. Large monoliths are unmaintainable. No, they're not. Poorly structured systems are unmaintainable. How we deploy them is kind of irrelevant to that. This is something we all need to internalize. By definition, microservices aren't more maintainable just because of the cardinality of their deployment topology. It's important to understand that we've got a couple different forces that we're thinking about in software. So we have the modularity, our ability to kind of change things, and then we have that distributability. Where can we put this thing? How does it get distributed? How does it get deployed? And so big ball of mud, probably everyone's least favorite pattern, although ironically also probably the most common pattern, not entirely sure how to feel about that, is neither distributable nor modular, right? It's like the worst of all worlds. So many of us are sitting here, we've got a big ball of mud and we see microservices and we go, whoa, that gives me everything. It's distributable, it's modular, I can scale it up, I can scale it down. This is awesome. I'm going to take my big ball of mud and I'm going to evolve it towards microservices, and everything will be wonderful. Angels will sing, the skies will open up. Except unfortunately, what happens is we mostly create distributed big balls of mud, which is the worst of all worlds, because I have all of the pain of the big ball of mud in terms of its inability to be modular, but now I've also tried to make it distributable, and this way lies madness. Don't ever do this. What works a lot better, frankly, is to evolve that big ball of mud to a modular monolith. And from there, if it makes sense, if it's a good idea, if we're going to continue to get value out of that, migrate that to microservices. And by the way, it tends to be easier to figure out what those microservices should be if we have a modular monolith first. We'll kind of have some ideas on where the seams are, where those bounded contexts might exist, et cetera. Now, you'll hear some people talk about right-size services or macro services. And this to me is just trying to figure out what's Goldilocks in this situation. To be very clear, some services, well, that'd be really way too big if we did it that way. Oh, that would really be too small if we did it this way. You've got to find out what's right for you in your situation, for your domain. Don't get so caught up in, well, is this the platonic ideal definition of a microservice? Well, it's 800 lines of code and I heard it's only supposed to be, 500 lines of code or something. You've got to do what's right for you and what makes sense in your situation. All right. So yes, sometimes we combine services together after we figure out these are really too fine grained. Sometimes we break them apart because we discover they're too coarse. Perfectly fine to evolve. We should be doing that as software engineers. Now, the other thing, I love this tweet too. Cloud native, again, does not require you to do microservices. You can have a cloud native monolith. And in a lot of situations, especially early on, it is the right thing to do. So don't feel like everything has to be a microservice just because, microservices. So yes, sometimes the right answer is modular monolith. So what are the principles that we look at when we're trying to figure out should something be a microservice or not? We're going to go through a few of them here today, and I'll have to leave the rest as an exercise to you to do later. Grab the report if you want to see all of them. First thing we look for is multiple rates of change. So inevitably in your system, some parts are changing all the time. Others haven't changed in months, maybe even years. So if you're in that scenario where some parts evolve at different speeds, microservices might indeed be able to help you. So we'll have our little widget.io monolith here. And so that's this fellow where we got like a recommendation engine and a cart and some account administration, et cetera, et cetera. Well, there's a pretty good chance that cart module is not really changing. I mean, let's be honest, add things to the cart, take things out of the cart. Maybe we plug in a different tax module or a different shipping module or something, but by and large, cart probably isn't changing. And you know what? We can't do anything about inventory anyway, because it's some green screen based mainframe thing that the warehouse folks use, and they are in no mood to change. So, okay, fine. We just have to work with them. But boy, we'd really like the recommendation engine to be better. And I've never once in my career had someone say to me, search is just too good. Can you make search suck a little bit? Just doesn't happen. Now, in a monolith, everything had to move at the same rate. And I do think fundamentally that's why we settled on this quarterly release cycle in the past, because we know it's a pain to push anyway. So we might as well wait until we have all the changes batched up, and then we'll push that to production. And, I have to push the entire monolith anyway, so I might as well. Now, that does have some really interesting unintended side effects, because what happens when we push hundreds or thousands of changes? Well, stuff breaks. And then we look at each other and like, why did it break? And it's like, I don't know. It was probably some interesting combination of these 7 features, and we had no idea that this was going to happen once we put them all together. Now, luckily for us, we have options today. We don't have to do it that way anymore. We can actually split things out, and we can allow the parts of our system that need to move faster to move faster. So maybe we split out the recommendation engine and the search piece to be their own microservice. And so now I can iterate those more rapidly than the rest of the system. I can get business value into production more quickly. And that's a big win for us, and it makes our customers happier. Now, that does lead to a really fascinating question is, well, how do I know what parts of my system change faster than the rest? Well, let's be honest, you probably already have an inkling here. So trust your gut. Don't be afraid to use that as your original guidepost. But having some data can be really, really helpful. Now, one of the simplest things we can do is just look at our source code management tool of choice. You can actually kind of get a heat map of sorts just by looking at history. Git in particular has all sorts of questions you can ask, and you can go basically tell it, please give me my top 10 list or my top 15 or 20, whatever you care about. So I ran this against the Spring code base at one point, which, to be very clear, is not a monolith, but it's an easy code base for me to get my hands on. And so I ran it just for fun, and this is what I got back. Now, you will be shocked to know that the change log changes a lot. No one could have predicted this. Now, I don't know the Spring code base well enough to tell you whether it's interesting that the configuration class parser changed a lot or the type descriptor changed a lot. I don't know. Every time I look at this, I think I should really talk to somebody on the Spring team and just say, hey, what does something like this mean to you? Is this what you would expect to see or not? So on your project, this is probably going to tell you or reinforce some things you already know or suspected, although don't be surprised if there's a couple things you're like, oh, that's interesting. So this gives you a place to start. And now you can practice what many of us have done our entire career, which is software archaeology. So roll up your sleeves, root around in your code base, and my apologies to Sir Isaac Newton, look for smoother pebbles and prettier shells. In other words, what Michael Feathers has called churn. Now, Feathers was looking at this in terms of where should we refactor our code base? And then that's kind of the same idea here for us. Pretty decent chance you're going to see a long tail distribution inside your project. That's a very common thing to see. Some project files are updated all the time. Others, we committed it and then never looked at it again. Now, Chad Fowler took this a step further and created this concept of turbulence, where he combined churn and complexity together to say, again, these are probably really good candidates for us to refactor. Now, there are some code forensic tools out there that we can leverage. And I don't have a dog in this fight, but as I was doing research, I did run into this one. So I'll use this just as an example of the kinds of things that these tools can show us. Again, I don't have any particular preferences, or I've not used code seen in anger, but it just gives you an idea of what some of these tools can do. And so I was looking at one of their example dashboards, and as you kind of poke around, you start to see some interesting information about where certain files get a lot more attention than others, and you start to get some trend lines. Trends are interesting to me as an architect. Are things getting better over time or worse over time? So 800 lines of code, that seems pretty reasonable to me. It's a decent amount of commits. A lot of it seems to come from one person. That might be a little bit of an issue if we've got like a single person dependency. A decent number of defects here. And yep, we just touched it this month. So unsurprisingly, this file gets a lot of attention. We get this interesting little trend line here. You take any kind of complexity number with a bit of a grain of salt in these applications. So I'm really just looking at the fact that obviously some things happen. Oh, we did some refactoring. Some things happened. We did some refactoring, and we've kind of plateaued. Maybe we could make it simpler. Maybe we couldn't. Who knows? It's hard to say. I'm not familiar with this code base, so I don't have strong opinions there. We also get something like cyclomatic complexity, which is one of my favorite metrics to run on a code base. And if you're unfamiliar, that basically says, how many paths are there through a particular function? So every time we could branch, that's another tick on the cyclomatic complexity box. We can have an interesting debate about what's a good number, what's a bad number, but I would say you want to be a low single digit number. Clearly here we switch from everything's fine at 4 to 5 as a warning, a yellow color. And I don't know where exactly it switches over to orange or salmon or red, whatever that is. I think 46 is really too high. And my experience tells me that once this gets into kind of that 4, 5, 6 range, you need to start refactoring aggressively, because this code base is going to get out of hand. If you get into the double digits, even the low double digits, like, here, 12, 13, 14 is still yellow, that gives me some pause. That's when you want to start thinking about what's my exit plan to get off this project, because it gets messy in a hurry. I believe the worst code I've ever run into on stuff that I had to work on was 82 or something to that effect. It was in the 80s. And this was code where they literally labeled brackets so you could try to identify, this was the closing bracket for which one of these loops and which one of these if blocks. And it was horrible. You had to scroll right to actually see real code. And believe me, that's where we began our refactoring effort, unsurprisingly. We also kind of see complexity versus lines of code. They tend to mirror one another. That's not too surprising. So again, I think we get an idea that these things kind of got better, and then there's refactoring, and then things got worse and refactoring. But we're seeing a fairly good trend all in all, and comments apparently are almost non-existent here. This must be that magic self-documenting code. We also start to see who's working on what, and do we have any situations where maybe we have a single person dependency that we might want to address. You never want to be in a scenario where one person wins the lottery and you're like, uh-oh, we don't know how to maintain this entire aspect of our code base because that person now is independently wealthy and they put in their notice this morning. Now, again, I'm not saying you have to use a tool like this or even this specific tool. We can get a lot out of our source code management tool of choice. You poke around on GitHub, you very quickly see when was the last time somebody committed to this file. And so if the last commit was roughly timed with a super blue blood moon eclipse, that's probably not a good candidate for a microservice. If you've got something that's constantly being updated, well, let's dig a little deeper and see if there's more to the story. Your defect tracker will tell you some information as well. Where do the bugs live? That's usually a pretty good indicator there's a problem there. Talk to your business analyst folks, your product owner folks. What's the locus of attention? Where are we really spending a lot of our energy? So now we should have some good candidates. So what do we do now? Just like nuke and pave? That way lies danger. I've been there. I've seen the end of that movie, got the t-shirt. This is where the strangler fig comes to the rescue here. And then this is a pattern that Martin Fowler identified many years ago now. It's kind of gone through a little bit of a rebranding, if you will. But it was based on these vines that he saw, these fig trees in Australia where they grow over the tree and basically, kind of take over the tree, so to speak. And it's the same idea for us, that what we want to do with this strangler fig application is ultimately replace the old bits with new bits over time. right? So in a nutshell, build the new around the edges of the old, and then replace those heritage bits as we go, as opposed to the big risk of the big bang cutover, which I've done more times than I care to admit in my career. That's really risky, because for most of these big bang kinds of projects, I'm telling my customers for months, trust me, we're almost done. You're going to love it. It's going to be great. And then after many, many, many months, we finally show it to them. So I'd much rather deliver business value incrementally, get some credibility, have the ability to show progress to my stakeholders, and adapt, by the way, as they look at it and say, well, this is great, but what we really would like is this instead. Now, we can take this a step further and actually apply data to the process. Here's the reality with a lot of these existing systems. You look at it and you say, what does the old system do exactly? And I have on more than one project been told that my requirements are it should work just like the old system, only better. And then you stare at each other and you're like, what does better mean in this context? So what does the old system do? We're not really sure. We're not sure. None of those original developers are here. None of the changes have been documented. And my wife's a business analyst. This is a conversation she and I've had repeatedly. She goes to great effort to identify these requirements over the course of a project, but as defects happen, as changes happen, we almost never go back and update the documentation to say, well, actually, when this strange combination of dates happens, then this is what the requirement is. We usually almost never get a chance to go back and update that. So we probably don't understand all the nuances of all the defects that have been fixed, all the patches, all the things that have been applied over many, many, many years, which means as we start replacing it, well, we introduce, or I should say reintroduce, a lot of those old bugs, and we rediscover these edge cases, and it's like, oops, didn't know about that. Well, what if we actually had real world data about what the system does, how it responds in given scenarios? And then this was something that was originally discussed at Spring One a few years back, which is let's apply data to the Strangler Fig approach. And what this idea says is let's put a proxy between the client and the legacy system. And the first job of that proxy is just to log the results. So here's the request, here's the response, and you run that for a couple of weeks, a couple of months, whatever you need to get a good idea of what the old system does. And so after some period of time, you now pretty much have a good idea of how the old system works, which you can then use as ammunition for the test cases that probably don't exist on the legacy system. Now, that's not the only advantage of this proxy. We can actually leave that running around once we have the new microservice in place, and we can run it in parallel with the legacy piece. And then the proxy layer can look at the results from both of them, right? So it still is sitting in between. It gets the request, routes it to both modules, gets the results back, and compares them. If everything matches, life is good. If they don't, well, we should probably default to the heritage response for now. But let's add that somewhere to a report, or log that out, or put that in a database so that a human being can look at it later. And just let's make sure that the old system really was working the way we expected it to. There is a surprisingly good chance that the old system was wrong. I've seen that on multiple occasions. It's where you're like, oh, we had no idea it did that. We had no idea it worked that way. The next big feature we look at, or principle here, would be independent life cycles. Now, clearly, monoliths are big ships. They don't turn on a dime, but that just doesn't work for us today. We really have to embrace that always be changing mindset. We have to be able to run experiments, do A/B testing, be much more responsive to our business partners. I know I've mentioned this earlier in the week, but when I first got into software, it seemed like every estimate I gave was 18 months at least, and that worked for some value of work, but it just doesn't fly today. I need to be able to turn things around in days or weeks, not months or years. And this was something that was really kind of brought home to me at the first Spring One I attended as an employee. A gentleman from Scotiabank got up and talked about their journey from doing, the traditional quarterly releases to doing thousands of deploys a month. And some of my colleagues from my previous organization were there, and we were having a conversation in the hallway. And they're like, well, Nate, we can't do that. And I said, why not? So, well, you've worked with us for years. We can't do that. And I said, well, did you not see the Scotiabank presentation? I mean, that's a bank. Banks are pretty conservative organizations for many good reasons. So if a bank can make that change, pretty sure you can too. Now, to be clear, this doesn't happen overnight. This is something that takes time and effort, and it takes some engineering discipline. You might need some new tooling in place. but it is absolutely doable for all of us. And even if it's inconvenient, I'm sorry, speed matters. Disruption's coming for all of us. None of our industries are immune. So if we return back to our widget.io monolith, what happens if our business partners identify this exciting new opportunity, but we need to be able to turn things around for them quickly, days, weeks. That quarterly release cycle is just not going to do it. We need to be able to answer this challenge much more rapidly than that. Well, what if we pull Project X out as its very own microservice? So now it's independent of everybody else. It has its own repository. It has its own build pipeline. It has an independent life cycle. Now, this definitely gives us speed to market. This is a good thing, but it also gives us developer productivity. I've been on a lot of monoliths. You have these ginormous getting started guides. You have build phases that are measured, build times measured in phases of the moon. I was on one project where builds routinely took 24 hours to complete, which means you'd check code in on Tuesday and you wouldn't know you'd broken the build till Thursday. And then you're trying to figure out what you were even working on at the beginning of the week. And can you even get your system back into that state? Probably not. It was the same organization where it was about a year before you were kind of productive in the code base. It's not great, Dan. So what was your longest stretch from you're hired, you're in the code base to now I'm actually productive? If I have smaller scope, it's a lot less for me to get my head wrapped around. That's a huge win. My builds finish quickly as opposed to taking hours or a day, which means I can fix build breaks much more promptly. It's going to be much simpler to fix these or test these systems as well. I was on one project and I made a suggestion and my test lead just stared daggers at me. And I said, you have some input. And she said, please don't make that change. I said, go on. She said, if you make that change, I have to spend 80 hours doing a manual regression test on that. And I just don't want to do that. I'm like, okay, fair point. Let's find something else for us to do here. So now I can have a nice set of fine-grained tests that can run on every commit. I can do performance tests on a regular basis. It doesn't have to be this one-off that we do just before we go to production and then throw the results in a drawer because there's nothing we can do about it now. It also lets me use the right tools for the job, for this particular service. What does it need? The big challenge with shared life cycles is we're at the mercy of whatever the longest tent pole happens to be, whatever the slowest moving part of the application happens to be. That's what is our governor on this project. Now, if you've ever gotten a t-shirt at a conference that's like one size fits all, you might wonder who that all person is. It's not great. And we don't want to be that way in a project either. Much better that we are able to tailor the solution for what's in front of us. So now each microservice can use whatever mix of tests makes sense for that microservice. Each microservice can use whatever linting rules are necessary for that project, for that piece of the code base. It can also help us figure out what our fitness functions should be. Basically, how do we test our architecture? How do we make sure that as we're evolving, we're not breaking some really important key component of our architecture? It also means we can practice hypothesis-driven development, which basically says, don't guess. Let's get data. Let's actually, do that research to say, will this improve sales, improve conversions, et cetera? I love this attributed quote, prediction is very difficult, especially if it's about the future. How many hours have you spent in the proverbial project room debating possible solutions? Oh, if we do this, it will definitely increase conversions. It will definitely increase orders. It will definitely increase signups or whatever metrics you care about. But how do you know? It's just conjecture in most cases. And more importantly, what happens if you're wrong? The big challenge with the monolith here is we had to be conservative. We had to take small steps. I live in the Midwest. It's fall. We're rapidly approaching my least favorite season, winter. I don't like the cold. I don't like the snow. I don't like the ice. I'm not entirely sure why I live here, to be honest with you. But one of the things I noticed as my son was going through elementary school, around this time of year, signs would start showing up in the hallways in his school, reminding the kids to walk like a penguin. Because if you take big, long strides on icy ground, you're going to slip and fall. And hopefully you land on your butt, not your face. And it's just a reminder, you have to walk differently, you have to drive differently when the roads are snowy and icy or sidewalks icy. You just have to be a little more conservative. That's the way we've had to work with a monolith forever. We couldn't afford to make a mistake in a 3 or 4 month period. Well, microservices mean I can actually test my hypothesis. I can even do A/B testing. But I can actually do something like this. I can say, we believe this change will result in this outcome. We will know we have succeeded when we see this change in this metric. So we believe adding a distributed cache will result in faster startup times. We will know we have succeeded if startup time is less than 15 seconds. This can be a whole boatload of useful fitness functions right here. Now, traditionally, A/B testing used to be something that only the big tech companies could do. There's that apocryphal Google tested 42 shades of blue or something. I don't know if that was true or not, probably not, but it makes for a good story. This is actually something we can all do now. And to be very clear, what customer doesn't want a constantly improving product? What customer has said to you, nah, everything's good, I don't need you to change anything? Now, if we want this to work, though, we really have to focus on paved roads. It can't just be a free for all, everybody do whatever they want. And this is really how things work, even at the most ingrained developer autonomous organizations. Sure, you're free to do what you want. Understand, though, that we have a well-worn path. We know how it works. We know how to support it. We've put thousands and thousands and thousands of instances through it, and we're really good at it. If you want to go on that minimum maintenance road, good luck to you. Hope you've got your tire chains with you, because it could get a little rough out there. You have four-wheel drive too, right? Okay, you got a big off-road vehicle. Good luck. This is the other side of that coin. Developers get very excited about the autonomy and they forget about the accountability piece. You build it, you own it. Now, the other aspect of this, and I know I talked about this earlier in the week, is the only way you get good at something is by doing it again and again and again and again and again and again. If you only deploy a few times a year, there's no chance you can get good at it. So far better to deploy early, deploy often. It will force you to buff off those rough edges. You'll get better at it. You'll also trust the process. Now, yes, that does mean we need good, robust pipelines. We need, there's a lot of good tools out there. Use whatever makes you happy. If you're not sure how to create a pipeline, my friends on the Spring team have some thoughts here. It's an opinionated build, test, stage, prod, flow, which, to be very fair, is a place to start. You can modify to your heart's content. Now, I'm very much of the opinion that independent life cycles are the most underappreciated benefit of doing a microservice architecture. It's also one of the most powerful. And one of my key sort of go-to phrases is, that's how we've always done it. Just doesn't work anymore. We can't afford to go back on that and say, well, we've always done it that way, so that's the way it has to be. It doesn't. We have to evolve. We have to change. We have to recognize we don't live in the same environment that we did even just 10 years ago, 5 years ago. We have to be ready to change from there. Now, of course, developers get very excited about microservices because polyglot tech stacks, AKA I can finally justify using whatever language or database or technology I've been dying to put on my resume, otherwise known as resume-driven design. Now, monoliths kind of forced us to standardize on a given toolkit, and almost every organization I've been a part of has described themselves by their stack. We're a Java shop, we're a Ruby shop, we're a .NET shop, and it's just another way of saying I've got a really big hammer. Somebody please bring me a problem. Now, there are some positives to this approach. If you've spent 5, 10, 15 years with a platform, you're going to get pretty darn good at it. It can make it easier to shift teams or people across teams, whether that's just to cross-pollinate, whether that's to balance out workloads. It can simplify hiring and training as well. And it certainly allows our operators to just focus on one or two primary environments. But again, one size fits all just doesn't end well for most of us. And there are some downsides to this. In a lot of these organizations, these sort of monocultures, currency was almost always constrained by whatever your slowest moving app happens to be. So no, you can't have nice things because the Wombat app's not ready. I have lost track of how many times I've wanted to upgrade my Java version only to be told, I'm sorry, you can't do that because insert important applications not ready to do it. And you'd ask some, probing questions like, well, when might they be on board with that? And the answer is always, well, 3 or 4 or 5 years from now. And that's when you start beating your head against the table and wondering what life choices brought you to this point. The other thing I've seen an awful lot is we do an upgrade and it takes so long that by the time the new version comes out, it's already outdated. Now, let's be honest, almost no organization is truly homogeneous. And even if you were at one all Java shop or an all Ruby shop or an all Python shop, guess what? We just bought another company, or we were acquired, or we merged, and we now have a new tech stack. Not once have I ever seen the technologists involved in the early stages of the M&A process we're always brought in after the champagne has been popped and, the senior executives all got their big payouts. And it's like, okay, you got to make this fit into that using nothing but this. Good luck to you. And by the way, you've got 3 months. Now, cloud computing helps. It does remove this sort of one stack to rule them all constraint, because I actually can spin up multiple different environments. And so polyglot programming, it's not just a pipe dream anymore. Again, though, they're just tools, and we need to make sure we're picking the right tool for the job, and so that we're not trying to force the proverbial square peg into a round hole. Now, there's always a but. Sorry about that. Always a but. We have to be very, very aware of technical sprawl. It's very easy to say, oh, it's great, we all just use the right thing for the job. And if Java works for you and .NET works for me and Python works for them, awesome. But what that means then is every single team potentially and every developer is going to have their own favorite tool, their own favorite language. And well, this is how we do pipelines, and this is the metrics we care about. And the next thing you know, you don't have 2 or 3 ways of doing it. You have as many services as you have ways of doing it. And that way lies madness. We can have an interesting debate about, how should we hire developers? How should we interview developers? I actually had a conversation with a former student of mine about that earlier in the week. And here's the challenge I see here, though, is how do you staff up for this? How do you find the magical, mythical developer who knows Go and Haskell and Ruby and Python and Java and .NET, C++? And, who does that person exist? Probably not. How many libraries do we need to support all of that as well? And more importantly, can we stay current with all of those things? The defects we're seeing now, some of these leaks are massive. And the number of people impacted are in the tens, if not hundreds of millions of people. And I think everybody is familiar with the Equifax hack. And of course, they were blown away by this Exactus hack, which is blown away by the Marriott hack. And T-Mobile just got hacked. I mean, everybody seemingly is getting hacked. So it can't be a free-for-all. That way lies madness. So we're going to have some kind of guardrails in place. And they could be very broad guardrails. It could be use whatever language you want, as long as it runs on the JVM. In my previous organization, we had 3 flavors. If one of these won't work for you, well, we'll have a conversation with you, but just be prepared. The answer is almost 100% going to be no. You can make it work with one of these languages. But we ultimately have to focus on paved roads. And again, this is what's happening even at the most developer autonomous organizations. Here's a well-worn path. We know it works. We know how to support it. We've done it thousands and thousands and thousands of times. We're really familiar with it. If you choose to go on this other path, I mean, that's fine. You're the one who's accountable for it. And you're the one who, if you made a bad choice, there's going to be an uncomfortable conversation in your future. Sprawl has a tendency to exacerbate our accumulation of technical debt. That shouldn't be too much of a surprise. Again, the key word here is micro. They're supposed to be small. And yes, I fully agree. We could debate the meaning of small until the cows come home. This, again, is why I'm rather partial to that. Anything we can rewrite in 2 weeks or less, because if I screwed up, I just blew an iteration. That's okay. I can recover from that. The other thing we have to realize is the more time that we spend on something, by definition, the more invested we are. I'm convinced teenagers are the way they are because if they acted that way when they were younger, we'd eat our young and they would never make it to teenagerhood. By the time you have a teenager, you're like, oh, I remember when they were so cute and cuddly. And well, I know this too shall pass. And you've already got so many years into them. You're not willing to sort of kick them to the proverbial curb. Same with software. If you've spent months using a particular solution or a particular technology and it's really not the right idea, you're going to keep coming up with reasons why it is. So it makes it a lot harder to change course, even if we should. So yes, microservice does free us to choose the right technology for the job. But I would like to remind you that innovation is not the same thing as just using a new language or a new framework or a new technology. I'm sorry, that's not how it works. It is incumbent upon us to weigh the pros and the cons. And we really need to remember Uncle Ben's wise words. With great power comes great responsibility. At the end of the day, you have accountability that comes along with that autonomy. You build it, you run it, you own it. You must avoid the temptation of resume-driven design. And I know how hard that is. I really do. So yes, microservices really do give us some very impressive benefits, but those benefits aren't free. They do come with a price. So please don't pay that complexity tax unless you're getting something in return. So no, not everything needs to be a microservice. use them where they make sense, use them wisely, use them where they add value. Now, we didn't get through all the principles today. We'll leave that as an exercise to you to look up later. But if you need one or more of these principles, by all means, go forth and prosper. Microservices are probably going to help you. If not, don't worry, there's always serverless. All right, friends, I've got some time for questions. So what can I do for you here this evening? How can I be of service to you? Questions or comments? Drag the chat over so I can see it. Thoughts, comments, theories, queries? Anything I can do for you today? Don't be shy. I don't bite. I love answering questions. I'll use that as an excuse to hydrate. Scan over here and make sure no one's got their hand up. All right, well, either that means I did a really good job or I put y'all to sleep. Either one's a possibility. All right, well, it doesn't look like we have any questions this evening, so I very much appreciate your time. Oh, there we go. What will replace microservices? Oh my gosh. You know, if I knew the answer to that, I'd probably already be working on it. I mean, it's inevitable that we'll just keep refining these techniques. You know, I can make a pretty strong argument that microservices are really just SOA done right. And this is, oh, no problem, Victor. The reality of these things is we've done the same thing again and again and again, right? So if you look at microservices, refinement on SOA, SOA is kind of a refinement on what we try to do with like EJBs. EJBs are sort of an alternative approach to Corba. You know, we keep trying to solve the same problem. So it'll be interesting to see what we're all focused on in 5 or 10 years. And thank you, Victor. I appreciate that. I sort of feel like WebAssembly has a chance to be a pretty big deal here, although, you know, I've felt that way about other technologies, and it is always hit or miss, to say the least. You know, things that you think are can't miss turn out to miss pretty widely. So it's going to be interesting to see where that goes. It's possible we'll see more of sort of the functions as an option, although that way also has issues, and there's some interesting trade-offs with sort of that approach. My hope is that we will pick the right tools for the problems in front of us instead of just reflexively reaching for the same thing. Now, in terms of what's my favorite framework for building microservices, I'm obviously rather partial to Spring for various reasons. You know, there's an awful lot of sort of similar moving parts in these distributed applications. And so using a framework that helps remove some of that boilerplate is in your best interest. You know, we don't want to be reinventing the wheel on every project for how to do monitoring and how to do tracing and, you know, what are we going to use for circuit breakers? You know, you should be using off the shelf pieces for the majority of that. So, you know, I'm not a big believer in hand rolling answers to these, although I've seen that more often than I care to admit. So I'm rather partial to Spring for various reasons. So any other questions or comments, anything else I can do for you? And certainly if you think of something later this evening or tomorrow, feel free to ping me on Twitter. You know, I'm pretty easy to find, and, you know, I'm always happy to come chat with you as well at your organization. You know, so if any of this is interesting, feel free to reach out, and you know, we'll swizzle stick a way to come hang out with you. So customers that say, no, I do not want a better system, at least if they pay for it, and testing is crucial. My company thinks it's overhead, unnecessary time loss. Yeah, Marcel, that's a good point. Some of it is making sure we describe it in words that make sense to them, and try to help them see why it is in their best interest to do it, quote unquote, the right way. You know, so most customers may not say, well, I want the system to be more maintainable, but they'd sure like us to be able to build features and functionality more quickly and get that into production for them more quickly. Well, you know what helps me with that? testing, refactoring, maybe breaking things up in a different way. So it's on us to make sure people understand why this isn't just overhead. It actually is going to result in better code and ultimately cheaper code. It's that idea of take the time it takes, so it takes less time, as part of that. And it definitely can be more of a discussion than it should be, but that's kind of on us to make sure that people understand what's in it for them and why it's in their best interest to do it the right way. So that's good point, Marcel. All right, well, I think at that, I am out of time. Again, thank you so much for your attention today. I really appreciate it. I hope you enjoyed the session, and everybody have a great week. And I hope to see you in person somewhere in the near future, maybe for some value of near. So thanks, everybody. Cheers.